Welcome to Module 1, Lesson 14. I'm Mrs. Gradney, and today we'll be using the subtraction algorithm again, this time decomposing to smaller units up to 3 times. And we'll be applying our learning to solve word problems using tape diagrams. Let's get started. Let's read this problem together. 22,397 minus 3,745. Now watch as I draw a tape diagram to represent the problem. What's the whole? 22,397 is the whole, and so I can label that here at the top. And we know 3,745 is part of the whole, so we need to think about how big to draw that part. Tell me when to stop to draw the part. If you said stop somewhere around here, great job. 3,745 is about 4,000, and that would be a really small part of 22,397. And so we can label the part here at the bottom. Now we still need to label the unknown, the part that we're looking for, and I'll label that using variable A. Pause the video now to draw the tape diagram like mine and make sure that you have the problem written vertically on your board as well. Welcome back. Now, when we're getting ready to subtract, think back to our previous lesson. What do we ask ourselves first? Are we ready to subtract? So let's look across the digits and say if we're ready to subtract. No, we're not ready to subtract. So what do we ask ourselves next? Next, we'll look at each column and we'll ask ourselves if there are enough of that unit in the whole to subtract the number of that unit in the part. Let's start with the ones. Are there enough ones in the whole to subtract the ones in the part? Yes, there are enough ones because 7 ones is greater than 5 ones. Are there enough tens in the whole to subtract the tens in the part? Yes, there are enough tens because 9 tens is greater than 4 tens. Are there enough hundreds in the whole to subtract the hundreds in the part? Nope, there aren't enough hundreds because 3 hundreds is less than 7 hundreds. So what will we need to do? We'll need to unbundle. We can unbundle 1,000 into 10 hundreds, so that will give us 1,000 and 13 hundredths. Now we're ready to subtract in the hundreds. So let's move to the thousands. Are there enough thousands in the whole to subtract the thousands in the part? No, there are not enough thousands because 1,000 is less than 3,000. So what will we need to do? We'll need to unbundle. We'll unbundle 1 10,000 into 10 thousands. That will give us 1 10,000 and 11 thousands. Now we're ready to subtract in the thousands. Let's move to the 10,000s. Are there enough 10,000s in the whole to subtract the 10,000s in the part? Yes, of course there are, because 1 10,000 is greater than no 10,000s. So now, are we ready to subtract? Yes, we're ready to subtract. 7 ones minus 5 ones is 2 ones. 9 tens minus 4 tens, 5 tens. 13 hundredths minus 7 hundredths, 6 hundredths. 11 thousandths minus 3 thousandths, 8 thousandths. 1 10,000 minus no 10,000ths, 1 10,000. Let's read the whole number sentence. 22,397 minus 3,745 equals 18,652. Now remind me, how can we check our subtraction using addition? Pause the video and talk out your thinking. Hopefully you remembered that we can add the part that we already knew with our answer, the other part, and what we should get as the sum is the whole that we started with. Pause the video now to check our work using addition. Hopefully, you got a sum of 22,397, which tells us that our subtraction was correct. So what's the value of A in our tape diagram? The value of A is 18,652. And we can record that underneath our tape diagram. Let's try another one. Read the problem with me. 210,290 minus 45,720. Pause the video now and record this problem vertically on your board. Take care and be careful to make sure that you line up your units, ones with ones, tens with tens, hundreds with hundreds, and so on. And also draw a tape diagram to represent the problem. Welcome back. Here's my tape diagram. Does yours look similar? I used the variable b to represent our unknown. You may have used a different variable, and that's okay. Now we want to subtract, so we need to ask ourselves, are we ready to subtract? Let's check. Nope, we're not ready to subtract. So let's get ready. Are there enough ones in the whole to subtract the ones in the part? Yes, there are enough ones because 0 ones equals 0 ones. Are there enough tens in the whole to subtract the tens in the part? Yes, there are enough tens because 9 tens is greater than 2 tens. Are there enough hundreds in the whole to subtract the hundreds in the part? Nope, there aren't enough hundreds because 2 hundreds is less than 7 hundreds. So what will we need to do? You probably said that we need to unbundle 1,000 to make 10 hundreds. But there's a 0 in the thousands place. So what can we do? Since there's a 0 in the thousands place, we'll need to go to the 10,000s and unbundle. We can unbundle 1 10,000 to make 10 thousands. Now we have some thousands to work with. Now we can unbundle one of those thousands to make 10 hundreds, and so we'll have 9 thousands and 12 hundreds. Now we're ready to subtract in the hundreds. Let's check out the thousands. Are there enough thousands in the whole to subtract the thousands in the part? Yes, there are enough thousands because 9 thousands is greater than 5 thousands. Are there enough 10 thousands in the whole to subtract the 10 thousands in the part? Nope, there aren't enough 10 thousands because 0 10 thousands is less than 4 10 thousands. So what will we need to do? We'll need to unbundle or decompose 100,000 to make 10 10,000s. And that will give us 100,000, 10 10,000s. Now we're ready to subtract in the 10,000s. Are there enough 100,000s in the whole to subtract the 100,000s in the part? Yes, there are because 100,000 is greater than no 100,000s. So are we ready to subtract? Yes, we're ready to subtract. Pause the video now to complete the subtraction. As you subtract each unit, whisper the subtraction in unit form. Then check your work using addition and complete your tape diagram by labeling your variable. Welcome back. Check your work with mine. Let's read the subtraction equation together. 210,290 minus 45,720 equals 164,570. Let's apply what we're learning now to solve a word problem. Remember, we use the RDW process to help us make sense of word problems. So let's read the whole thing together. Ready? Read. Bryce needed to purchase a large order of computer supplies for his company. He was allowed to spend $859,239 on computers. However, he ended up only spending $272,650. How much money was left? Now, before we dive into the drawing, take a moment to think about what's happening in the problem. How would you explain in your own words what's happening in the problem? Pause the video to explain. I have a friend over here who was saying that the amount of money that Bryce was allowed to spend is all the money. That's the total or the whole amount. The amount of money that he spent is part of the total, and the amount of money that's left, which is what we're looking for, is the other part. Pause the video now and draw a tape diagram to model the story. Be sure to label the whole, the known part, and label the unknown part with a variable. Here's my tape diagram. Does yours look similar? I used the variable M to stand for money. You may have used a different variable, and that's okay. Now, let's look at our tape diagram and think about what it tells us about how we can solve. In the tape diagram, we can see that we know the whole amount, and we know one part, and we're looking for the other part. When we know the whole and one part, and we're looking for the other part, we can subtract to find the other part. Tell me the problem that we'll need to solve. 859,239 minus 272,650. Pause the video now and record the problem vertically and solve using the algorithm. Remember to ask yourself if you're ready to subtract and to get ready to subtract in each unit before you start subtracting. And don't forget to write an answer statement to answer the question. Welcome back. Remember to compare your work with mine. Hopefully you found that $586,589 was left. Great job today, friends. I think we're ready for the problem set. The must-do problems for the Lesson 14 problem set are on the screen. Set a timer or watch the clock for 10 minutes to work on these problems. If you finish the must-do problems within those 10 minutes and you still have extra time, feel free to try any of the other problems on the problem set as well. Today, we used the subtraction algorithm and we decomposed to smaller units up to 3 times. We also applied our learning to solve word problems using tape diagrams. Remember to check in with your teacher, and I'll see you next time for another Eureka Math lesson. Bye!